Statisticians use confidence intervals to describe the amount of uncertainty associated with the sample estimate of a population parameter. Often researchers choose 90%, 95%, or 99% confidence levels, but any percentage can be used. Confidence intervals consist of two parts. The first part is the estimate of the population parameter, sample statistic, and the second is the margin of error, which is derived from our desired level of confidence and the standard error of the sample statistic. The sample statistic is in the center of the interval. We then add and subtract the margin of error from this statistic to obtain a range of values for the parameter. To calculate a confidence interval, you need to first choose a sample statistic, x bar or p hat, that you will use to estimate a population parameter. Second, you will select a confidence level, 90%, 95%, or 99%. You calculate the margin of error next. The margin of error is the product of the critical value, which is associated with the z-score for our desired level of confidence, and the standard error of the statistic. To find the critical z-value, subtract your desired level of confidence from 1. For 95% confidence interval, this would be 5%. This is the percentage of confidence intervals based on the various samples that could be drawn from the population that would not contain the population parameter. For a 95% confidence interval, this means that 5% of those confidence intervals would not contain the population parameter. You divide that result by 2 because we are estimating an interval around a center point. So some of the error needs to be above that value and some needs to be below. In this example, it's 2.5%. In terms of the standard normal distribution, this means that we're looking for a z-score where 2.5% of the area under the curve is above that value and 2.5% is below it. It turns out that 95% of the area under a curve is between a z-score of plus and minus 1.96, which is slightly less than 2. This is why I became so precise in my numbers when discussing z-scores in the previous module and when introducing the standard normal curve earlier in this module. You can certainly use 2 as your critical value, but it will actually result in a confidence interval that is slightly bigger than 95%.